Assalamualaikum. My name is Muhammad Adi Arianto. My metric number is 01 DKM 22F1045. Today, my group and I want to present about our project proposal, which is an alternative route to mitigate issue in an existing hydroponic farming system. Okay, next slide. For the first one is our research background. Addressing challenge in urban agriculture, hydroponic and plant health. Urban agriculture, particularly in hydroponic, face challenges such as declining agriculture space and reliance on distant food source, worsening food insecurity and environment poverty. Hydroponic present a promising solution, but the absence of the reliable nutrient mix in water tank pose risk to the plant vitality, making worse by algae clogging the pump. Urgent practical solutions are needed, including a precisely designed intervention to ensure the pump's seamless operation, free from algae, and providing the nutrition and water for the plant. This approach safeguards plant health and strengthens urban agriculture rules in promoting food insecurity, environment sustainability, and resilience urban ecosystem. Interdisciplinary collaboration and advanced technology hold promise in transforming city into sustainable food hub. Okay, next slide is our problem statement. The lack of a proper nutrient mix in the hydroponic water tank put plant at risk of nutrient deficiency and or deaths. The absence of an effective and integrated nutrient mix in water tank pose a significant risk for plant vitality in hydroponic system, potentially leading to plant death or nutrient deficiency. Nutrients are essential for the plant growth, but many plants perish due to not enough nutrient supply from the tank through the pump. Additionally, pump malfunction or algae clogging in the tank can hinder nutrient and water delivery to plant, further risking their growth. An urgent need exists for innovative solution to ensure proper pump operation and prevent algae clogging, thereby providing ample nutrient and water to support plant growth and facilitate crop harvesting for farmers. For next slide, is our objective for problem 1 and project 1 and project 2. Okay, for project 1, identify why is no suction in pump inlet. Identify the problem and constraint of said objective 1. Determine possible solution to said objective 2. Develop and implement solution to mitigate pump clogging hydroponic system. Objective for our project 2 to design filter before the suction in the pump inlet of a hydroponic tank. Fabricate the said filter in number 1, test and evaluate the said filter in number 2. Okay, for the next slide is our scope. Research and analysis. Conduct through research on filter type for hydroponic system. Analyze effectiveness. Design and development. Create a tailor-fit design considering dimension, material and configuration. Prototype testing. Fabricate prototype for registrating and evaluate filtration efficiency and durability. Optimization. Refine the filter design based on prototype feedback for enhanced effectiveness. Implementations. Develop installation procedure and training for personnel. Reading the filter for integration. Monitoring and maintenance. Establish a maintenance schedule for regular monitoring, cleaning and replacement of the filter. Okay, next slide is our literature review. Okay. In the first journal, we refer to the introduction of hydroponic, which commonly used. We can analyze the advantage and disadvantage of this system. Okay, for second journal, because the spray nozzle often clog, continuous maintenance is required for the system. Continued maintenance is necessary for the system due to the poverty of spray nozzle to clog, which can block the proper functional of aeroponic system. Regularly, attention is required to ensure the nozzle remain clear of any obstruction, thus maintaining optimal misting efficiency and preventing any disruption to growth of the plant. Okay, the third journal. Additional filtration is particularly crucial when dealing with fine root plant species due to their propensity and shredding smaller fragments that can easily infiltrate and clog the supply line. Fine roots are good at removing tiny particles, which is not properly filtered out, pose a significant risk of obstructing the flow of nutrient solution through the system. Therefore, implementing effective filtration mechanism become imperative to ensure the smooth operation and longevity of the hydroponic setup, especially when accommodating plant varieties with delicate and compact root structure. Okay, for the last journal, as we can see, the horizontal hydroponic design can cause clogging problem because there is no angle, which means 90 degrees. So the design must have a bit of the angle to make the water flow smoothly, and there is no stagnant water. Okay, for the next slide, I pass to my next presenter.
Assalamualaikum. My name is Izri Azim bin Azizul. My matric numbers is 01 DKM 22F 1121. So I want to present my flow chart for this project. This is our flow chart that we use as our guideline to attain this project for this semester. We begin by forming group, then brainstorming ideas to our likings. Then we working on the case study, survey and data collection from users. After the data was collected and analyzed, we found that the data was in line with the problem we discussed for our project. After that, we went on to create house of quality table. Then we start to do morphology chart to decide our own design. We also do hue chart after we got our own design to look which design is suitable for the environment. Next slide is this is how each concept is developed. Next slide is survey need analysis. Our group go to Jabatan Pertanian daerah kita to make a survey and analysis for how they using hydroponic system and ask them if they any problem when using hydroponic. According to the officer that in charge, there was a blockage in the water pump that prevented water from getting to the growing pipe, which led to the death of the planted trees. Second, we do is questionnaire. According to the question above, most of the users, 41.9%, often eat vegetable 5 to 7 a week. So we need to make sure the pot capacity of the design can fulfill the needs of the user. Next slide is next question. According to the question above, 64.5% of users face the same problem, which is clogging. We can conclude that clogging is the most common problem among hydroponic users that need to be solved. And this is morphological chart. This is our morphological chart that we have done to decide our own design for this project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amiruddin bin Muhammad Zawahir. My matric number is 01 DKM 221044. And today I'm going to be explained by the conceptual design. And this slide, there are 4 concepts. Each concept can be clicked on and there will be figure shown in each concept. Next the first concept is created by Muhammad Adi Arianto. It can save space, it can be put anywhere in your home without using a lot of space. Then that's cheap. The material used to assemble this concept is very cheap compared to the current hydroponic design. This concept is also highly portable because it can be assembled and disassembled without having any problem. It's also eco-friendly because it uses a small water pump, and the material made to make this concept does not use any clay. And lastly, this concept is also lightweight and can be carried without having to use any gardening tool. Concept 2 is created by Muhammad Taufik Hakim bin Dahrum. The description is safe space, lightweight, eco-friendly, easy to assemble and disassemble, and can store lots of land. For the next concept is created by myself, Muhammad Amiruddin bin Mawazawahi, and it is eco-friendly, durable, can plant lots of land, and has a large capacity of water. And lastly, this concept is created by Izzuddin bin Azizul. It is eco-friendly, durable, easy to assemble and disassemble, and also more to aesthetic design, which look elegant and can be placed anywhere in the living compound. And the last slide from me is our group chat, where we decide which design is the best based on the selection criteria. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Taufik Hakim bin Dahrum. My metric number is 01DKM22F1046. I will explain about our group's final design. Based on the view chart, we as a group came to an agreement to pick this design as our group final design because it scored the most positive points in the view chart. Next slide is the ISO drawing of the final design. Here is our design's ISO drawing. The model is made by assembling 7 different parts using AutoCAD Inventor. Next slide is the water pump filter ISO drawing. This is our own design water pump filter that will be attached to the pump inlet to combat clogging problem in our hydroponic system, and hopefully one day will be used in every hydroponic setups around the globe. Next slide is the fabrication and testing. First, growing pot. In the first step, we need to take 7-inch PVC pipe and cut it into 7 pieces using a saw. Make sure we cut it into the same size for all pieces. After that, we cut 1 inch for the pothole every 45 degrees to get 2 holes. Next, we use a heat gun at the pothole cutting to make the PVC pipe soft. So we insert 1-inch pipe to open the cutting into a hole. Wait until it cools before touching it. Next, filter. We use the 3D printer to make the filter for the water pump inlet. Finally, assembly. First, we put the water container on the ground, placing the water container lid on top. Then we are going to connect 1 inch of pipe to the center of the water container lid to use it for the water flow to the top and as a frame to make it stable. Next, connect the mini submersible water pump to the underside of the water container lid. Proceed by staging the growing pots from one to another. After that, fill the water container with nutrient-rich towers and load the tower seedlings. Lastly, connect the submersible water pump to the power source. In this project, we use a solar panel as the power source, so we connect the pump with the power to the solar panel. Lastly, on the water pump and at the top of the tower, see if the water comes out of the pipe. Next slide is the estimated cost of our final design. This is the estimated cost of each component of our hydroponic design. These prices are based on our research and comparison made on online stores pricing as well as our local hardware stores pricing. Next slide is the fabrication costing. Cost for 3D printer service is RM3 to RM5. Fabrication cost is $0 because the fabrication is done by ourselves. Next slide is the project impact. This project has a positive impact on the urban community by reducing clogging problem in the hydroponic system, therefore making it easier to manage hydroponic system in urban setting, thus encouraging urban community to cultivate using hydroponics, indirectly transforming cities into vibrant hubs of sustainable food production and community resilience. Next slide is the conclusion. To conclude, clogging problem can have several implications like reduced nutrient flow, uneven distribution of nutrients, root health issues, and many more. Addressing clogging problem in hydroponic system is crucial for sustainable urban agriculture because it ensures efficient use of resources, maximizes space, conserves water, maintains food security, reduces costs, minimizes environmental impact, and keeps the community engaged. By tackling clogging issues, urban farmers can create more effective and resilient hydroponic setup, helping to produce fresh food in cities while minimizing problems that could affect productivity and sustainability. That's all for our presentation. Thank you very much.